Everyone remembers airships as a dream. Silent, elegant, peaceful. A future that almost happened. Not airports. Not security lines. Not engines screaming against the sky. Just a floating hotel crossing the Atlantic. A dining room above the clouds. A smoking room inside a machine filled with hydrogen. A promenade where passengers could look down on the ocean and feel, for a moment, that humanity had solved gravity without violence. But there is something missing from that image. Something physical. Something structural. Because an airship is not only a vehicle, it is a building, suspended under a weather system. And when the weather changes, the building has to fly. That is the part the dream never shows. You are not cutting through the sky. You are being carried by it. And when the sky stops cooperating, control becomes negotiation. The first mistake is comparing an airship to an airplane. A plane survives by speed. It generates lift by forcing air over wings. It is violent, precise, unstable by nature, and controlled by constant correction. An airship is different. An airship begins with buoyancy. It does not defeat gravity. It offsets it. Above the gondola, above the crew, above the passengers, there is an enormous volume of lifting gas. Hydrogen, helium, structure, fabric, valves, cells, rigging, control surfaces, engines, ballast. The machine is not dense. It is huge because it has to be huge. And that hugeness changes everything. A plane can be small and fast. An airship must be vast and slow. The larger it becomes, the more surface area it gives to the wind. The more surface area it gives to the wind, the more the weather can touch it. This is not a design flaw. It is the bargain. You are not inside a vehicle. You are inside a volume of gas, larger than a cathedral. Imagine the passenger experience. No vibration, no pressure, no roar. The ship feels calm because the violence is hidden in scale. The frame distributes stress. The gas distributes weight. The crew trims the ship constantly, keeping it balanced between fuel burn, ballast, temperature, altitude, and weather. To the passenger, this feels like effortless luxury. But effortless systems are often the most fragile. Because the more invisible the correction becomes, the more shocking it is when correction fails. An airship in calm air feels inevitable. An airship in changing air becomes a question. How fast can something that large react? How much authority do control surfaces have when the entire body is a sail? How do you turn a floating building when the air itself is moving sideways? Now the dream becomes mechanical. The Hindenburg was not flown casually through weather. Its officers studied weather constantly. Weather was not background. Weather was strategy. Zeppelin navigation used pressure systems, wind patterns, and storms not only as dangers, but sometimes as tools. The ship could gain speed by using large atmospheric movements. But that tells us something important. If the atmosphere can help you that much, it can also dominate you. The same invisible river that carries you faster across the Atlantic can push you where you do not want to go. This is the quiet truth of airship travel. The route is not simply chosen. It is negotiated with the sky. And the sky has no contract. Take the most dangerous moment. Not cruising. Not the cinematic disaster. Descent. Approach. Ground handling. The transition from sky system to land system. A plane lands on wheels. An airship arrives like a weather event that must be captured. Ground crews, mooring lines, masts, ballast, engines, wind direction, static electricity, rain. Pressure. The airship is no longer simply flying. It is being converted from one state to another, from floating mass to anchored object. That conversion is where the dream becomes labor. If the wind shifts, the ship does not become smaller. If the ground crew pulls, the sky still pulls back. And if the captain waits too long, the correction may arrive after the mass has already committed. This is the hidden physics. Large systems do not respond instantly. They absorb. They lag. They overshoot. The public sees a graceful body. The crew feels inertia. A control input begins at a wheel, moves through cables, surfaces, air pressure, mass, trim, and time. The result is never immediate, and the larger the body, the more the environment becomes part of the control system. This is why the airship is beautiful and terrifying for the same reason. It is gentle because it is slow. It is dangerous because it is slow. The easy story says airships failed because of one disaster, because of hydrogen, because of Hindenburg, because cameras were present at the exact moment the dream burned. But that is too simple. Hydrogen mattered. Fire mattered. Public fear mattered. But the deeper issue was systemic. Airships required a world built around them. Hangars of impossible size. Specialized crews. Weather intelligence. Ground infrastructure. Gas supply. Maintenance. Slow travel economics. And a public willing to accept that the most luxurious way to travel was also one of the most dependent. Not on pilots alone, on atmosphere, on labor, on prediction, on calm. Airships did not fail because they were primitive. They failed because they revealed something uncomfortable. There are systems too large to control directly. You can guide them. You can trim them. You can predict around them. But you cannot dominate the sky. And once you see that, the old dream changes. The airship is no longer a lost future. It is a warning from a future that understood scale too late. You do not want to fly. You want the sky to agree. And the sky does not always agree.